Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Keto-enol tautomerism requires at least one alpha hydrogen, a hydrogen on a carbon adjacent to the carbonyl. The degree of enol content depends on factors such as intramolecular hydrogen bonding, conjugation aromaticity of the enol form, ring strain, and electronic effects. Moving on to the next step. The structure shown is a bridged bicyclic ketone, resembling phenchone or a gemdamethyl norcamphor. In this molecule, the alpha carbons to the ketone are bridgehead carbons, which cannot lose a hydrogen to form an enol, Brett's rule violation. Therefore, keto-enol tautomerism is not possible. This matches S. Moving on to the next step. Cyclobutane 1, 2, 3 trione has 3 carbonyl groups on a 4-membered ring. The enol form is highly stabilized because it leads to an aromatic or highly conjugated system. The enol of a 1, 2, 3 tritone on a 4-membered ring can form a fully conjugated aromatic structure. In fact, the enol content is essentially 100% because the enol form is overwhelmingly more stable, analogous to how squaric acid derivatives are highly stabilized by resonance pseudoaromaticity. This matches P 100%. And for the final step, acetylestone, pentane 2,4 dione, CH3C is equal to O, CH2C is equal to O, CH3 is a classic beta diactone. Its enol form is stabilized by intramolecular hydrogen bonding and conjugation across the C is equal to CC is equal to O system. In the pure liquid state, acetylestone exists approximately 76 to 80% in the enol form. This matches Q 76%. Ethyl acetoacetate CH3C is equal to O, CH2C is equal to O, OET is a beta ketoester. The enol form is stabilized by intramolecular hydrogen bonding, but the ester group is less activating than a ketone because the lone pairs on oxygen partially donate into the ester carbonyl, reducing its electron withdrawing character. Therefore, the enol content is lower than in acetylestone, approximately 8% in the pure liquid. This matches R 8%. A. Bridged bicyclic ketone with no accessible alpha-H keto-enol not possible S. B. Cyclobutane 1, 2, 3 trione 100% enol due to aromatic pseudoaromatic stabilization P. C. Acetylestone 76% enol due to strong intramolecular H bond and conjugation Q. D. Ethyl acetoacetate 8% enol due to weaker activation by ester group R. Therefore, the correct answer is AS, BP, CQ, DR. The correct answer is shown on screen.